So what exactly do you have in common with a parasitic tapeworm? Yeah, I know, probably not the question you were expecting to start with today, but it actually turns out the answer to that question is basically the ultimate key to your health, your energy levels, and how your body processes literally everything you eat. You see, the term metabolic flexibility was actually first coined by scientists to describe how parasitic worms, helminthes if we're being specific, adapt their internal energy generation to survive these super unpredictable, rapidly changing environments inside their host's habitat. They can just seamlessly switch back and forth between aerobic and anaerobic respiration. And as we're going to see today, your own body performs a really similar, highly complex balancing act every single day.
Welcome to this explainer on mastering your metabolic engine. Today, we're going to look at your body as if it were a highly adaptable, state-of-the-art hybrid vehicle engine. We're talking about an engine that doesn't just run on one single type of fuel, but instead it's constantly shifting gears and fuel sources, depending on what you're doing, what you're eating, and get this, even what time of day it is.
Okay, so let's just dive right in and define our core concept here. Metabolic flexibility is, officially, the ability of an organism to respond or adapt according to changes in metabolic or energy demand, as well as prevailing conditions. Now, in human terms, that basically represents your internal engine's ability to seamlessly switch between burning fat and burning carbohydrates, or glucose, throughout your day. When you're metabolically flexible, your body is super efficient. It automatically utilizes whatever energy source makes the absolute most sense in that exact moment. And mapping out our chronological journey through a normal day perfectly illustrates what this looks like in action. Think about it. While you're sleeping, your skeletal muscle is relying heavily on fatty acid oxidation. It's burning fat. But when you wake up and eat, well, everything flips. Fatty acid oxidation drops way down and glucose oxidation and storage skyrocket. Then when you decide to exercise, the whole engine just revs up entirely, pulling heavily from both systems to meet those enormous energy demands. That right there, that's the beautiful dance of metabolic flexibility.
Section 1. From fasting to feeding, the daily fuel switch.
All right, let's zoom in on that first major shift we all experience every single day when we wake up. In the fasting state, so right before breakfast, your body's relying heavily on fat oxidation. Your insulin levels are nice and low. But the very moment you eat a meal, bam, you enter the feeding state. The absolute crucial point to remember here is that insulin release in response to your meal is the primary driver of this fuel switch. Your body actively shifts away from burning fat, moving straight toward glucose oxidation and storing that dietary fat. This amazing shift efficiently moves you from a catabolic breakdown state over to an anabolic state, where you're safely storing energy in your muscle, liver, and fat tissues.
Section 2. The white adipose buffer. Rebranding body fat. You know, when we talk about fat storage, we usually think of it as this completely inert, stubborn locker where excess calories are just dumped and forgotten. But we really need to radically update that view. White adipose tissue, or WAT for short, is absolutely not just a storage unit. It's actually a highly active, dynamic fuel manager. It acts as a buffer for circulating free fatty acids to safely supply energy for peripheral tissues like your skeletal muscle. It's constantly orchestrating this continuous cycle of taking up fats, esterifying them, and then releasing them. And in a healthy person, this tissue is incredibly sensitive to insulin. So why does all this matter? Well, because when WAT acts as a proper buffer, it safely sequesters those fats and prevents dangerous ectopic fat deposition, which basically means it stops fat from building up inside your liver or your muscles, where it can cause some really serious metabolic harm.
So what happens when that buffer totally breaks down? If we look at Transcapillary Flux, which is essentially the net fat storage and release in abdominal white adipose tissue over a 24-hour period, it reveals a really stark difference. For lean individuals, we see these beautiful, dynamic peaks and valleys responding to every single meal. They're actively storing and releasing fat, right on cue. But for abdominally obese individuals, that flux is basically flat. The adipose tissue has completely lost its flexibility. Because it's no longer actively storing dietary fat after a meal, those free fatty acids just remain in the bloodstream. They're roaming around, and unfortunately, they end up getting deposited in places they really shouldn't be.
Section 3. Gearing up for exercise. The extreme metabolic test.
Okay, we've talked about sleeping and eating, but now we're going to turn the engine all the way up to the red line. 25. Now, this isn't just a random number. Rigorous exercise can demand a 25-fold increase in energy expenditure compared to our resting metabolic rate. I mean, just let that sink in for a second. 25 times. Your skeletal muscle suddenly accounts for more than 95% of your body's total energy requirements. To survive this massive spike, your body has to pull from intramuscular glycogen, triglycerides, circulating glucose, and plasma fatty acids, all at the exact same time. Exercise really is the ultimate extreme test of your metabolic flexibility.
And this dynamic builds a really fascinating case for physical training. Imagine a state of acute lipid oversupply. Basically, you're flooding the engine with a ton of fat. When highly trained subjects are flooded with this fat, their muscles gracefully adapt. They decrease glucose oxidation, increase fat oxidation, and crucially, they manage to preserve their muscle glycogen storage. But the untrained subjects? Oh man, they experience total metabolic gridlock. They can't effectively burn the extra fat, and their precious glycogen stores are just diminished. So training literally upgrades your internal engine software to handle fuel way more intelligently.
Section 4. Fixing metabolic inflexibility. Tuning up the engine.
So what exactly happens when the engine is broken, leading to issues like insulin resistance and conditions like type 2 diabetes? And maybe more importantly, how do we actually fix it? Well, to tune up a broken engine, you literally have to remodel it at the cellular level. Now, while interventions like calorie restriction are absolutely fantastic for weight loss, research actually shows it doesn't necessarily enhance your skeletal muscle's capacity to oxidize fat. Chronic exercise, however, is an entirely different beast. Exercise training increases mitochondrial biogenesis. That means it literally builds more higher functioning power plants inside your cells. It promotes massive changes in the epigenome,
the transcriptome and the proteome. This profound cellular remodeling is the real secret sauce that enhances both your insulin sensitivity and your capacity for fatty acid oxidation.
Section 5. The circadian connection, timing your rest. But hey, an engine can't just run at the red line forever, right? To make these amazing cellular tune-ups stick, we have to talk about the timing of our recovery. Our metabolism is deeply, intimately tied to our circadian rhythms. In fact, the American Heart Association defines optimal circadian health as aligning your internal, roughly 24-hour rhythm to the external light-dark cycle. This alignment is what maintains your physiologic and behavioral homeostasis. Remember that whole journey through a normal day we talked about at the beginning? That entire process of switching from fat burning at night to glucose storage during the day requires a biological clock that knows precisely what time it is. If your internal clock gets all misaligned because of, say, late-night light exposure or just irregular daily habits, your metabolic flexibility is absolutely going to suffer. And the American Heart Association makes such a powerful point on this. They say sleep timing regularity is as important as sleep duration. Think about that. Going to bed at 10 p.m. one night and then 2 a.m. the next, even if you manage to sleep for a full 8 hours both times, completely confuses your metabolic engine. A flexible, highly functional metabolism requires strict circadian alignment. Your body simply needs to be able to predict when to deploy insulin, when to release fatty acids from that white adipose tissue, and when it's time to just shut down and recover.
Which brings us to our final big question for today. With everything we've uncovered about this incredibly complex, beautifully synchronized dance between your skeletal muscle, your dynamic white adipose tissue, those mitochondria, and your 24-hour circadian clock, we really have to ask, could a pharmaceutical exercise pill ever truly replicate this whole shebang? I mean, sure, drugs can definitely target specific fuel pathways, but true metabolic flexibility, that requires a concomitant increase in energy demand, that massive 25-fold increase that only real physical exercise provides. It requires your epigenome to adapt to real physical stress and your circadian clock to perfectly guide the recovery. The science points to one really profound conclusion here. There are simply no shortcuts. To master your metabolic engine, you have to drive it hard and you have to rest it properly.